Balancing long chemical equations, like this one, are a nightmare if you try to do it by guessing. You change one coefficient, something else breaks, and you end up starting all over. In the midst of all this blind problem solving, linear algebra gives us a clear way to understand what's really happening. In order to use linear algebra to balance this equation, we're first going to refer to each compound as a variable x multiplied to a vector. For potassium manganate, since there is 1 potassium, 1 manganese, 4 oxygen, and 0 sulfur and 0 hydrogen, the entries are as follows. Once that's done for the whole equation, we're left with the same expression, just now with x's, which represent the ratio of each compound needed to balance the equation, and the element vectors. Now, to solve this expression through an augmented matrix, we must move all the non-zero vectors to the left, so that everything equals the zero vector, as we do to solve any algebraic equation. In doing so, the vectors that were initially on the right side of the equation are negated now that they are on the left side. Then, we can combine all the vectors to produce an augmented matrix. Now, to solve this matrix, you can either do it by hand using row operations, or you can use a calculator's RREF, reduced row echelon form function, to yield the matrix in reduced echelon form. This form makes it easy to solve each equation which is represented by each row in the matrix. Turning this matrix into equations, we come up with a solution set, ending with x6 being a free variable, given that there are more columns than rows in the matrix. A free variable means that instead of getting one solution, we get infinitely many. That's because there are more compounds than independent conservation rules. The chemistry fixes the ratios between coefficients, but not their overall size. In linear algebra terms, this means we're finding the null space of the matrix. Each solution in the null space represents a set of coefficients that balances the equation. From this perspective, stoichiometry is really about ratios, which is why multiplying a solution by any constant still works. Chemistry textbooks choose the smallest whole number solution, but mathematically they're all valid. If we do choose the smallest whole number solution, we can set x6 to 2 to cancel the denominator of some of the solutions, getting us the smallest whole number solution set. As mentioned in the beginning, the solution set represents the ratio of each compound in the balanced equation, or the coefficient for each compound. So, to produce our final balanced equation, we simply have to multiply each x to its respective compound for a balanced equation. In this fascinatingly fun way, we can see how linear algebra doesn't replace chemistry. It helps explain why balancing equations works at all.